Welcome back to OSS Master Series. I'm your host Balaji Kumar. Today we are stepping into modern era, the cloud native era. This is episode 6 of the Master Series, OSS in the cloud native era, agility, scale, and resilience. If episode 1 through 5 explained how OSS, the operational support systems, evolved, a little bit of the history, OSS evolution, episode 6 explains where OSS is going. Because the truth is simple. Telecom has changed. IT has changed. Customer expectations have changed. And OSS must evolve to keep up with it. In general, OSS lags all of these things. But it comes to a point where OSS has to keep up with all the changes happening. Today we explore how OSS becomes cloud native, modular, scalable, resilient, and fast. Why cloud native matters. Before I jump into the details, let me make sure to the audience, I'm not going to be explaining all the details of cloud architecture and cloud aspects, which is in general applicable not only for telecom, but any enterprise software or applications. You can find tons of information on that from various cloud providers and third-party influencers. Legacy OSS was built for a world of static networks with predictable load and slow change. Today's networks are dynamic, distributed, and constantly evolving. 5G, IoT, Internet of Things, edge computing, and last but not the least, AI, artificial intelligence. All demand agility and scale with unpredictable, dynamic customer traffic expectations and applications usage. Cloud native OSS delivers that agility. It allows operators to deploy faster, scale instantly in real time or near real time, and recover automatically in case of failure, and innovate continuously. This isn't just a technology shift. It is a mindset shift. What cloud native OSS really means is a stateless, no dependencies on local storage, scalable, grows and shrinks automatically based on capacity needs, resilient, self-healing and self-tolerant. API first, everything is programmable and connect to any other applications or any other third-party vendors to solve a problem. Containerization, packaging of the software in a self-sustainable and being portable. OSS is designed for cloud from day one. It is not lift and shift as the industry uses the terminology, where you take the old software and put it in the cloud native environment, not running the old systems in a virtual machine, but truly cloud native. And let me make sure everybody understands that all of these options are being used and deployed as we speak today. But we are going to be focusing on the real cloud native and its benefits for OSS. Let's start with the old world. Before cloud native OSS was monolithic, on-premise, which means was deployed in data centers within an operator environment. Was hard to scale because self-contained in a physical computer, hard to upgrade, hard to integrate. A simple upgrade could take months because we are talking about a distributed set of computers running multiple applications and really pushes the limits of planning, testing, and downtime aspects in such a way that the network should not be disrupted. In other words, scaling means buying bigger servers with more memory, more storage, more CPU. Integrating means custom adapters, both physical and logical layers, API layers. Recovering from failures meant long nights in the network operation centers where you got to monitor all the traffic in real time to make sure the network doesn't fail. Our customer traffic is not impacted that much. And it worked to some extent. There were some failures once in a while, but in general, it worked. but it wasn't built for the world we live in now. OSS after the cloud native, basically the new world. We are not 100% there, but we're getting there. All the jigsaw puzzle pieces are in place now. Cloud native OS is built on a concept called microservices. Small, independent components that can be deployed, scaled, and updated individually. It runs in containers, orchestrated by a platform called Kubernetes, the de facto platform for cloud-native workloads, managing different containers. And it is integrated through APIs, application programmable interfaces, instead of proprietary connectors. It updates continuously through CI/CD process called continuous integration, continuous delivery pipelines. All of these things, it helps to recover automatically through self-healing mechanisms. This is the OSS designed for speed, resilience, and innovation. The benefit of cloud-native OSS are following. There are generally 4 major benefits cloud-native OSS delivers. Faster innovation. New features can be deployed on a weekly basis or even daily. Lower cost of ownership. Auto-scaling and efficient resource usage reduces the infrastructure cost. Better uptime. Self-healing, redundancy, and rolling updates eliminates downtime. And last but not the least, easier integration. API-first design makes OSS plug-and-play with the IT systems, cloud services, and automation engines. The cloud-native OSS isn't better technology, it is better business. The principles of cloud-native OSS consist of 4 core principles. Immutable infrastructure. If something breaks, you can replace it. You don't patch it. Declarative configuration. You describe the desired state and the system enforces it. Observability. Metrics, logs, traces gives you full visibility of the system behavior in real time. Automation everywhere. Deployment, scaling, recovery, the whole life cycle is all automated. These principles makes OSS predictable, scalable, and safe. Thus, a cloud-native OSS stack consists of the following things: components, containers, packaged workloads, Kubernetes, orchestration of those containers, service mesh, which does the traffic control and security for all the services running on top of Kubernetes, which will be on one or more containers. API gateways, integration, access control to all the underlying infrastructure, and getting information from external systems. This stack is the new foundation for OSS. Microservices, the building blocks. Microservices are nothing but individual applications which breaks the OSS into small and independent services. Each service handles one or more functions: fault management, inventory management, provisioning, performance analytics, ticketing, planning. They communicate through APIs and not shared database. This makes OSS modular, testable, and scalable. Containers and Kubernetes, the engine room. Containers package OSS components with everything they need to run. Kubernetes orchestrates these containers. It scales them, it heals them, it restarts, it distributes, it manages the basic lifecycle of all software deployment. Kubernetes is like a robot operations team, always watching and adjusting. CI/CD, the pipeline of continuous improvement. CI/CD, as I mentioned earlier, stands for continuous integration and continuous delivery. It basically automates deployment, testing, rollback, and version. It allows OSS teams to release updates safely and frequently. No more than 6-month release cycle. No more big bang upgrades, just continuous improvement. And automatic deployment across the network in a more managed and controlled aspects. and without impacting the customers. DevOps is a culture behind the technology. It stands for development and operations. DevOps is a culture of collaboration between development and operations. It emphasizes automation, monitoring, feedback loops, and shared responsibilities. In OSS, DevOps means faster delivery, fewer outages, and happier teams. Observability is the ability to understand what is happening inside OSS, which includes metrics, capturing the performance data, logs, event history, as things happen, keeping track of it, traces, request paths, traces all the things happen in sequence, dashboard, visual insights, rolling up of data and presenting it in a logical fashion. Without observability, OSS is flying blind. Not only OSS, even human beings are flying blind because so much automation is done in the back end. With observability, OSS becomes predictable, diagnosable, and manageable. Resilience patterns surviving failure. Cloud-native OSS uses resilience patterns like circuit breakers, stop cascading failures, retry logic handles transient errors, graceful degradation, reduce functionalities without crashing. These patterns keep OSS stable under pressure. Security built into the foundation. Security in a cloud-native environment includes zero trust. Never assume anything is safe. Always be self-dependent. Secret management to protect credentials. Role-based access, or we call RBAC. Enforcing permissions for the different users for different applications at different locations. Security is baked into it, not bolted onto it. The deployment models where OSS lives, it can run on a public cloud like AWS, Azure, or Google Cloud, or private cloud where you deploy the same software but on your premise with Kubernetes running but compatible with public cloud applications, or sort of hybrid where a mixture of both public and private cloud are deployed, an application running on both environments. The edge cloud is basically a cloud closer to the user where the applications related to the user is the one running on those platforms and not all the applications. It's typically deployed to save a lot of footprint and thereby cost. Each model has a trade-off in cost, latency, and control. Kubernetes, the platform of platform. When OSS runs on Kubernetes, it gains self-healing, auto-scaling, declarative control, rolling updates, multi-zone resilience. All of this as part of the platform and its application. Thus, Kubernetes becomes the backbone of cloud-native OSS. Service mesh. Intelligent communication. A service mesh is like an linker or istro managed microservices communication. It provides traffic routing, encryption, retries, observability, policy enforcement. It is like air traffic controller for microservices. API gateways, the front door of OSS. API gateway manages how external systems interact with OSS. Basically, it provides things like authentication, rating element, limitations, routing, monitoring, and makes sure that the access is given to the right people from the right location for the right applications. So they make OSS more secure, scalable, and manageable. Scaling and growing with demand. Cloud-native OSS scales horizontally. Kubernetes handles horizontal pod scaling, Autoscaling, cluster autoscaling, multi-region deployment. This ensures OSS can handle peak loads without breaking. Upgrades without downtime. Modern upgrades strategies are included blue-green deployments, canary release, rolling updates. These patterns often make upgrades safe, fast, and reversible. Disaster recovery built for failure. Cloud-native users automated backups, rapid restore workflows, multi-zone failures, replicated state stores. The goal is very simple. If something fails, OSS keeps on running. Cost optimization, smart spending. Cloud introduces cost optimization. Optimization strategies include smart instances, auto-scaling, resource quotas. Smart OSS team treats cost as a performance matrix. Observability stack. Full visibility. A modern observability stack such as Prometheus, Grafana, Earth, Elasticsearch, Logstash, Kibana. Most of them are open source platforms, and they work together and provide full visibility to OSS behavior. Since these applications are open source, it requires some amount of customization to your requirement, but in general, it has majority of the users' functional capabilities out of the box. The future of cloud-native OSS. The future includes OSS as a service, a fully managed OSS platform, a serverless OSS functions like event-driven, stateless, and scalable, and AI-driven OSS, predictive scaling, intelligent routing, self-healing, Egg OSS, local orchestration for low latency applications. GitOps. Git is another source of truth for deployments where the softwares are stored, or instances of the software is stored. Multi-cloud OSS, portability and federation across multiple clouds. Sustainable OSS, energy-aware scheduling and carbon tracking. Cloud-native operators. The operator of the future is going to be agile, data-driven, automation-first, cloud-fluent. This new skill sets that transforms operations from a reactive to strategic. In closing, the future is cloud-native. And that brings us to the end of episode 6, the OSS in the cloud-native era. We explored new concepts such as microservices, containers, Kubernetes, CI/CD, observability, orchestration, and the future of cloud-native OSS. In episode 7, we shift to OSS for service assurance and customer experience, the ultimate measure of network performance. Thanks for joining, and we will see you in the next episode. Please like and subscribe. Thank you very much.